So in this video I want to start motivating the next abstraction after functor that we're going to look at. So let's imagine we have a type of employee records. So we'll just say that name, we'll just make it a synonym for string, and we'll make a type of employee record. And I don't think I've used this syntax before. I'm going to say what it means in just a second. Using this syntax is incidental, but it's a nice place to introduce it, since it's fairly common in Haskell. So this is record syntax, where I've given a constructor for this type, and then in curly braces I've given these are the values that are going to be contained in this constructor, but each one I've given a name. So this is record syntax. It's essentially equivalent to if we had written something like data employee where I have the employee constructor, which contains a name and a string and constructs an employee record. But also we get some other nice stuff, like for example we get name can be used to extract the name of an employee, also phone, and plus some other nice syntax. I'm not going to go into it, you can look it up if you want. Like there's syntax for constructing these, for pattern matching on them, for updating a single field by its name. Anyway, so, but moving on, what if we have, we don't have a name and a string. So if we have a name and a string, we could put them together to make an employee record, right? Or an employee value. But what if we don't have a name and a string? Exactly. What if we have a maybe name and a maybe string? So for example, maybe we were parsing these from some data source and they might be invalid, or there might be a syntax error or something. Or maybe we were reading them from the network and there might have been some kind of transmission error, right? And so for various reasons we might not actually have a name, we might not actually have a phone number. And basically what we want to do, right, we want some kind of function of type, well, I'll call it maybe employee, which takes a maybe name and a maybe string representing their phone number and gives us a maybe employee. That makes sense, right? So if both of the maybes, if both of them are just, if we actually do have a name and a phone number, then we can really put together an employee. But if either of them is nothing, then we just return nothing, right? We can't actually make an employee record. So this is easy to write. I'm not going to bother, you guys could do it, you just pattern match on those arguments and you put together a just if they're both just, and so on. Right, but there's other kind of similar things. So what if we have something like, we have a list of names and a list of corresponding phone numbers, and we want to put together a list of employees, kind of by putting together, the first name goes with the first phone number, second name goes with the second phone number, and so on. Right, you all could write this too, this is also easy. Again, writing these is not the point. We're going to see a repeated pattern. So one last thing, maybe we'll call it extract employee. So what if we had, so imagine this is like E represents some kind of environment or some kind of data source or something where it's a whole bunch of information, but somehow we can extract a name from it. Doesn't matter exactly how, but we have a way, right? We have this function that tells us how to extract a name from an E. We can also extract a phone number from an E. Well, this means we should be able to extract an employee from an E, because we can basically run, we run this function on the E, we also run this function on the E, and we take that name and string and we put them together to get an employee, right? So that should be also straightforward to write. These are all right. Obviously, I hope you see the similarity between these. So we have some kind of context in which we can get a name, some kind of context in which we can get a phone number, and then we want to be able to produce an employee in that same context. So, right, all this motivates something like well, yeah, I guess I'll say, before I say that, I'll say, in general, we have the employee constructor takes a name and a string and gives us an employee value, but we are looking at things of the form, we take some, again, I'm going to be using f as like a generic kind of functor thing, just like we did when we talked about functor. So in this case, f was maybe, in this case, f was list, and so on, right? So I've got some kind of f name and an f string, and I want an f employee, right? And how do I do this? And so this motivates something like, maybe we'd call it, this is kind of like fmap, right? Fmap, put the motivates down here. Fmap has type A to B to FA to FB, but we apparently want something like this. I'll call it fmap2. So it takes not just a function from A to B, but like a 2-argument function from A to B to C, in this case corresponding to the fact that we can create an employee out of a name and a string. But then we want to be able to take an FA and an FB and give us an FC. I should write, sorry. There has to be a functor constraint there. And the question is, so we'll call this like G. G is my A to B to C function, and then we'll call this argument, we'll call it FA, we'll call this argument FB. And can we implement this? So I'm not going to answer that question in this video. I actually strongly recommend that you sit down and play with this and see if you can, either if you can implement it, how does it work, how can you implement it, and if you can't, can you come up with some kind of explanation of why it won't work.